right, guys, you survived yesterday. So if you survived yesterday, today's kind of a reprieve, so a little easier. So today we're talking about 3D figures. And just a couple of things to remind you. A polyhedron is a 3D figures whose faces or sides are polygons. So we have prisms, cylinders, pyramids, and cones. This here is a prism because it has two bases. A cylinder has, this is two bases that are polygons. A cylinder has two bases that are circles. I know this seems like you should know this. A pyramid has one base, that's a polygon, and a cone has one base, that's a circle. Okay, next, how many faces does this guy have? So if you counted all the faces, those are the flat surfaces, you should find 6 faces, again, 2 bases. So this is a base, and then if he was over here, this would also be a base. Okay. How many edges do we have? You literally would have to count them all. So 1, 2, 3, 4, 5, 6, 7, 8, and then on the bottom 9, 10, 11, 12. So 12 edges. How many vertices? So we can count all of these vertices. Those are these points. So that's 1, 2, 3, 4, 5, 6, 7, 8. So again, the base is the bottom face of a pyramid or cone. The bottom, and sometimes I like to say it's also the name. That's how they name things. A face is that flat surface in which connect at those edges to form those prisms and pyramids. An edge is that line segment form where two faces connect. The vertex is the point on a 2D or 3D figure. On a 3D figures, the vertices are where 3 or more edges meet. Now here's a formula. It's called Euler. Euler is a famous mathematician. And let's see if this is... you can see this better. So here's his formula where it helps us find those edges. To find edges, or you can use it to find other things. So you know how to rearrange this formula. So for example, if I wanted to find out how many faces, I would subtract the vertices over here. So you can rearrange this to find whatever you need to do. If I need to find vertices, I would subtract faces. All right, so let's try this. How many, so let's go back over here, I'm sorry, where F is the number of faces, V is the number of vertices, and E is the number of edges. So how many edges, so we're solving for E, and really we could literally, since that's what I'm solving for, I'm going to just rearrange this guy and subtract 2 from both sides. So really it's F plus V minus 2 equals E. So I'm just going to do that. So how many faces do I have? It says I have 10 faces plus 7 vertices minus 2 equals E. So 17 minus 2 is 15. So that's a nice easy way to figure those out. This is called a pentagonal bipyramid, because there's bi meaning 2, pentagonal, 5-sided. All right, let's move on. So here's what's called platonic solids. There are 5 important polyhedrons that are referred as platonic solids. There are only regular convex polyhedrons constructed by congruency. Remember, regular means all sides and all angles are congruent. They have polygonal faces with the same number of faces meeting at each vertex. Each is named by their faces. So this is different because there's no base. All right, so how many faces does this baby have? 4, kind of hard to see them, but you have 3 here, and I always look at this. So this is telling me that I have 1, 2, 3 that are going up to the point, plus the base, so that equals 4. And again, you can use that formula to figure that out as well. This one has 6 faces, 12 edges, and 8 vertices. This one has 8 faces, 12 edges, and how many vertices do you see? 1, 2, 3, 4, 5, 6 vertices. Or we could use that formula. Dodecahedron has 12 faces. How many edges? Now this is the one where you'd want to use that formula. And so let me go back to that formula. F plus V equals E plus 2. So we're trying to find the edges, so we're going to subtract the 2. So we have F faces plus my vertices minus 2 equals E. So what is that? 32 minus 2, that would make that 30 edges. That is a lot easier than trying to count them all. And isosahedron has 20 faces, 30 edges, and 12 vertices. So it has triangular faces. All right, let's move down here. Find the number of bases. So when you're looking at this, and visually you have to think of what this is going to look like when it is folded up. But since this has 2 bases, it would have to be a prism. What shape is the base? A triangle. Is it a polygon or circle? That's a polygon. And so this would be a triangular prism. Because we name it by the base. Next one, number of bases, 1, 2. So if we folded this in half, not in half, if we folded it up, these are called nets, by the way. So this is if you cut them a figure in part, a 3D figure in part, and laid it flat. That's what these are. So we have 2 bases, should be a cylinder. Shape of the base is a circle. That is a circle. And this is called a cylinder. Next, if I put all this together, then this would be my base. I have 1 base and should be a pyramid because of the 1 base. The base is a rectangle, appears to be a rectangle, which is a polygon. Therefore, it is a rectangular pyramid. And this is what these guys look like once they're folded up. Excuse me. This one also has 1 base. It is a cone. Hopefully you can see it's a cone. It is a circle. And it is a cone. So this next section is called a cross section. So with a cross section, if they cut it this way, so if you're cutting it horizontally, I always look down or at the top or the base. And that's going to tell you what that cross section is going to look like. So if you would slice this in half and open it up, what shape do you see? Now if it's a vertical line, I look at the side view. And this one would be a rectangle. So cylinder A appears to be intersected by a plane that is parallel to its base. So it's a horizontal slice. Since the bases are circles, then the cross section would also be a circle. This is intersected along a vertical axis. This cross section in this case would be a rectangle. And like I said, it's kind of that side view. Like if you would look at a cup and you looked at it, you know, sideways, you would see that shape as a rectangle. You have to think two-dimensional. And if you would look on top of the cup, you would see the circle. So cross sections. One type of cross section is plane symmetry. So that's what they call this. So let's take a look. So let's do these. Shape C. Start with that. What would you say that cross section is? I would say that's probably a square or a rectangle. Can't really tell. D, same thing, right? Square, rectangle. E, how many sides? 1, 2, 3, 4, 5. A pentagon. F is side, so look at the side. Think about that looking on the side. So if I was looking at the side, I'm looking at this space here. So that's a triangle. G is definitely a rectangle. I'm looking at it this way. Looking at that face. And then H, looking downwards, and so that's a circle. How about today being nice and easy for you? All right, that makes up for yesterday.